to describe in your own words any words that come to mind when you see the word slope. And when we describe, we use our beautiful bubble map. So, describe in your own words that tell me what slope is. So, one of the words that comes to mind that you guys said was mountain. What other word comes to mind? Skiing. Okay, so when you're going skiing, we go on the slopes.
Hill.
Okay, mountain, hill, kind of synonymous. Downhill. There was a couple of you guys that wrote downhill on your paper. And then in that case, downhill, and then the opposite of that is uphill. So, tilted. If I ask you to look at this beautiful mountain scenery, I use the yellow to accentuate the slopes of that mountain, like Hillary, whatever you call it, mountain hills scenery. What kinds of slope do you see?
Line.
What kinds of slope do you see?
Diagonal.
Okay, diagonal. So if we're going to go to the top of this mountaintop right here. Now, we read from left to right, correct? Except in Hebrew, but we're in English. So we're going to read from left to right. And when we go from left to right on this mountain, what's happening? Where am I going? How am I traveling? Downhill, correct? I'm traveling downhill. Similarly, if I begin at the left here, what am I going? You're going uphill. Does everybody see how this is uphill and this is downhill? So this one is up, that one is down. What about down here?
Sideways.
I'm traveling, but is there an up or down?
No.
What kind of a line is that? Is that vertical? It's horizontal. It's a flat line, correct? When you see the word or you hear the word flat line, and I associate it with something totally different like your heart, what is your heart doing? How many beats per minute is your flat line? Zero. Good. So keep that in mind. This is what we call a zero slope line. A downhill is, what do you think? Positive or negative? Negative.
One of those, like,
And uphill is,
circle things.
yep, positive. So when you go downhill from left to right, it is a negative slope. When you go uphill from left to right, it is a positive slope. If you have a flat line, a horizontal line, that is what we call zero slope. Because I could still ski that. I can get on my skis and I can walk across it, but it's zero fun. What questions come up out of this? The last kind of line that might come into play would be, if it's not horizontal, what is it? Vertical. Now, if I was to draw a line here and make believe that that is a slope, right there in the background, would I? No, that's vertical. Horizontal is flat. Horizontal is like the horizon. It's left to right. Vertical is up to down. Think of it as the blinds right here are verticals. They're called verticals because they go up to down. Now, I used to always get confused because there's also blinds that are horizontal. So I don't know why that was something that I always had an issue with. So vertical is up to down, up and down. So if I decided to ski the slope, if I decided to ski a slope that was vertical, let's look at that here. Okay? If I was on a mountain and I was going to go down this way, I could go uphill. I'd have to do a lot of effort, but I'd go uphill. That's positive. I could go downhill, but if I was to ski a slope that is straight up and down, would I survive it? No. because of gravity, it would totally throw you off. And what would really happen is, if you're going to be skiing, you're going to come out like this pretty much. Okay? So a vertical line is what we call an undefined slope. So I'm going to go over all of the different types of slope right now. When we talk about the slope of a line, we are referring to the linear functions that we discussed before the break. And linear functions, if you recall from before we went on brain break, linear functions are equations whose graph is a straight line. There is a constant rate of change, is what we call the slope of the line. And like I just showed you with the mountaintop, there are 4 types of slopes. The first type of slope is what we call a positive slope, because from left to right, it's going uphill. From left to right. Just like you read from left to right. The leftmost point that I can see going uphill, that's positive. Similarly, if I begin at the leftmost point and I go down, it's called negative. A flat line is called a horizontal line, and it has a slope of 0. 0 is still a number. So this is a slope. The slope is 0. If I ski a slope that is flat, I can ski it, but there's really no change. I'm just going constantly the same. As opposed to a vertical line, and if you guys remember how you can check to see if a graph of points is a relation, if it's a function, you do the vertical line test, and if 2 points are crossed by the same vertical line, then it's not a function. Well, a vertical line is really not a function, but it's still a line. So the slope of a vertical line is undefined, because you're really just changing the value from y to y, not from x to x, because the x is the same. Okay, so undefined slope is a vertical line. These two are special cases. These guys are regular, uphill positive, downhill negative. Any version of that is positive or negative. But these two are what we call a special case line, because the horizontal line has a slope of 0 and it crosses the y-axis. A vertical line has undefined slope and it crosses the x-axis. Notice here, a horizontal line crosses the y-axis. Here, the vertical line will always cross through the x-axis. So one of my students at one point actually created an acronym, or thought up of an acronym, to help him understand these two special cases. And that acronym he referred to as VUX-HOI. Vertical lines have undefined slope. They cross the x-axis. Horizontal lines have slopes of 0. They cross the y-axis. So VUX-HOI is just an acronym to help you remember these two special case lines. So if I ask you, what kind of a slope does a vertical line have? You can either go, oh, vertical line is always going to have undefined slope, because you can't ski that. You can't ski a vertical line, so it's undefined. Or you could say VUX, oh, vertical, undefined. And if I say, what slope does a horizontal line have? You could say, oh, a horizontal line, I could ski that, but it would be 0 fun. Or a flat line heart is 0 heart rate, and think of the number 0. Or you could say, oh, horizontal line, HOI, slope of 0, H-O-Y. H for horizontal, O for slope of 0. O is for the 0. So it's really H0Y, HOI. With that, when you're looking, you can always just figure out what the slope is, no problem. If you're thinking, if you make sure to think about it like reading a book. You read from left to right. So when you get stuck, and this is what I would always get stuck on, is I would always kind of just find a way to make it look the other way. And then I realized, okay, just like if I was reading left to right. If I'm reading left to right and I'm going uphill, it's positive. From left to right, I'm going down, it's negative. No change at all. It's flat, is 0, vertical, undefined. So those are just different ways of thinking about it. Now, when we're looking at the slope of a line, such as that which is written here in black, it is really important that you forever engrave in your brain that the slope of a line is what we call the rise over the run. This is what we talked about before the break. The change of y over the change of x. Change, that triangle is the Greek letter delta, which represents the word change. Delta y over delta x is the same thing as change of y over change of x. Think of it as a mountain, if you think of it that way. If there's my mountain right there, and I want to know what the slope is, I first will go up, because I change y, and y is vertical, and then I will go over. The amount of change vertical over the amount of change horizontal is the rise over the run, where the rise, once more, is the vertical change. So it's vertical change over horizontal change. This is very important that you understand, because a point is x comma y. So you will often make the mistake of thinking that it's change of x over change of y, and it's not. It's change of y over change of x. Change of y over change of x. Vertical change is the numerator. Horizontal change is the denominator when we're talking about slope. For that reason, slope will always be considered to have to be written as a fraction so that you could see the numerator and you could see the denominator. And the numerator tells you how much you changed vertically from one point to the next, and the denominator tells you how much you changed horizontally. So now let's actually watch this as it's used so that you do find some connection to it. Let's look at this here. Here we have a line. Looking at the line, not the red or blue, looking at the black line right here, you could see that from left to right, I'm going downhill, correct? So I immediately know it's a negative slope. Well, if the slope is change of y over change of x, this is the part that you're going to need to know how to do. You're going to find a point. Well, here's a point right there. Do you see that point right there? From this point to that point, which is the next point that I can see, the change of y, because remember, slope is change of y over change of x. The change of y is that I went down 1, 2, 3, 4 units. I went down 4 units, and so the slope so far is -4 for the y change. And then from this point here, because I went down 4, I went over 1, 2, 3 to the right. So that means that the change of x was 3. The slope of that line is -4/3 because you changed by going down 4 and then to the right 3. It's kind of like following a map. How did I get from this point to here? You're going to go down 4 units, then you're going to go to the right 3 units, and then put the next point. This is constant. That means that if I wanted to know what the next point down the line is, I would go down 1, 2, 3, 4 units to the right, 1, 2, 3. Here is another point right there. Here I have a line. I am asked to find the slope of the line right here. Just by looking at it, what kind of slope do I have? Downhill, which is called? Negative. So I know it's a negative slope. I'm going to keep that in my head, so I'm just going to think about that, so I know that when I get an answer, my answer is going to be negative. Now, slope. What is the slope of a line? Do you remember?
The y-axis over the change of the y-axis over the change of the x-axis.
Fantastic. Slope is change of y over change of x. Now, in order to see what change occurred in y, I am physically going to look at, from the leftmost point, how much did I move from the point to the next point vertically? Well, I know I'm going downhill, correct? So I know it's negative, and coincidentally, notice that from this leftmost point to this rightmost point, you're going to go down 1, 2, 3, 4, 5, 6, 7, 8. You went down 8. 1, 2, 3, 4, 5, 6, 7, 8. You are here. You went down 8. From 4 to negative 4, it's negative 8. That was the change of y. But slope is always a fraction. The change of x, yeah, you're going to go from this, right, from negative 4 to 2. So you're going to go over 1, 2, 3, 4, 5, 6. So the change of y is negative 8. The change of x is 6. It's now a fraction, negative 8/6. And what must I always do with fractions? Simplify them. So yeah, kind of divide, but we're going to simplify. We leave them as a fraction so you could see the numerator and you could see the denominator. So you could see what the change of y is, so you could see what the change of x is. But you simplify the fraction. What am I going to divide 8 and 6 by?
2.
Nice. That's going to give me negative 4 over 3, or negative 4/3. The slope of this line, which we use the symbol m for, m is slope. Think of mountain slope, m for, I don't know why they say m is for slope, but it is. The slope of the line is negative 4/3. All on your own. So try this one. So you're going to say, I'm looking for slope. Slope is change of y over change of x. And now you keep it as a fraction. Now you're going to actually calculate the change of y. Well, leftmost point to rightmost point. Here's the leftmost point. Let's change the color so you can see it better. And here's the rightmost point. Did I go up or down?
Down.
From left to right? Up. So in my head, I already know that this is a positive slope. I'm just going to keep that in my head. Change of y. Well, this guy, the y is at negative 1. And this one, the y is at 1. So from negative 1 to 1, it went up 2. Positive 2. Now looking at the change from left to right, my x is here, the x is here. I went over 1, 2, 3, 4, 5, 6, 7. I went over to the right 7 units. Don't forget to count 0 also.
I think that was 0.
1, 2, 3, 4, 5, 6, 7.
How do you know which one to do first?
So once more, and I know that it's kind of difficult to see it with it written on here. Let's see if I can delete this. Okay, here we go. Slope is change of y over change of x. You always begin at the leftmost point. The leftmost point is this one right here. Change of y means how much did you change vertically? Well, I started here and I ended up here. The vertical change, and if it helps you to draw out things, you're welcome to do that. You could say, well, the vertical change, the next point goes all the way up to 1. So that means the vertical change is 1, 2. I went up 2. That's the change of y. The change of x, here's my x. So notice, again, remember, when you're looking at y, you're looking at the y value. Here's the y, and here's the next y. It's up there. Change of x, you began here, and you ended at 3. So your change of x is going to be over 1, 2, 3, 4, 5, 6, 7. You always run to the right. The rise is how much vertical change occurred. You rose 1, 2, then you went over 1, 2, 3, 4, 5, 6, 7, and put the next point. So the answer to the slope of the line, the m, the slope, is positive 2/7. That's it. So you could actually also get slope if you do not have the line drawn out for you. To get the slope, it's change of y over change of x. Look at this guy. The change of y, well, from 1 to 3, I went up 2. From -2 to -1, I went up 1. So the slope is 2 over 1. Change of y over change of x. The slope, the change of y for this specific table of values for this relation, I went up 2, up 2, up 2. That's the change of y. The change of x was up 1, up 1, up 1. So the slope of this relation, of this function, which is linear because it's constant, is 2 over 1. The other way, if you are a very verbal person and you're not very visual, this method might be more helpful to you to find the slope of a line than figuring out how much you go up or down and over. This is the mathematical formula to find the slope of a line. If you're not given the 2 points that have been plotted and connected, in order to get the slope of a line, you are going to be given 2 separate points. Point 1, you will see written as a point at 2, 5. Point 2, another point. These numbers down below are called subscripts. They're not exponents. x1, y1 is symbolic of the x value for your first point. y1 is symbolic for your y value of your first point. So what does x2 mean? X value of your second point, y2 is the y value of the second point. So if you want to know the difference between the y's, what operation do we perform?
Slope.
If I want to perform the difference between two numbers, what operation? Add, subtract,
Rise,
multiply, or
rise.
divide?
Subtract.
Subtract. So if you want to know what the change of y is, you're asked to find the difference of y's, which means that you are going to subtract your two y values. So you're going to take this y value, y2, minus this y value, y1, and that's going to be the change of y. So what do you think that change of x is going to be?
X1.
x2 minus x1. Subtract the x's, and that's your denominator. That's your change of x. Subtract your y values, and that's your numerator, because it's change of y over change of x. If you subtract y2 minus y1 on top, you must do x2 minus x1 on the bottom. But if you decided to just do y1 minus y2, then you have to do x1 minus x2. Order matters. So, for those of you that are very visual, if you're given the line, you can identify the leftmost point, and you can figure out how much did I change vertical? That's the change of y. How much did I change horizontal? That's the change of x. So it's that over that as the fraction. For those of you that are very verbal, very literal, and you really need to understand the how-to, what are the 2 points? Oh, 2, 5, 7, 3. 2, 5 is x1 and y1. 7, 3 is x2 and y2. y1 or y2 minus y1 is the numerator. x2 minus x1 is the denominator. Boom, you have your fraction. Let's see exactly how this works. Here are 2 points. I ask you, find the slope of the line. Well, you could, if you wanted to, make a graph. -2, comma 2, -5,
1 over
comma 3.
7.
Connect the dots, and then count change of y over change of x. Or you could go, forget that. You're giving me the point values. I'm not even going to graph it. Change of y over change of x is the difference of y's, so 3 minus 2 over the difference of x's, -5. And remember, I started with 3, so I have to start with his x. Minus -2. Very careful with that, because you're minusing -2, which becomes plus 2. So if I was to,
1 over negative.
nice, 3 minus 2 is 1, -5 plus 2 is -3. One of the things is negative, so that means the whole slope is negative. When I look at it, I graphed it wrong. -2 comma 2. Oh, I plotted this wrong. I did 5 comma 3, and it should have been -5 comma 3. Do you see how I graphed it wrong? So I was too quick to talk about it. I was too quick to graph it. Do you see how I made that mistake? But when I fixed it, I could see that it's a negative slope. Okay, so what's the slope of B? -5 minus 6
0 over 1.
over -5 minus 6
Negative.
over 3 minus 3, change of y over change of x. Which is the 0, the numerator or the denominator?
The one on the bottom.
Yeah, what happens when I divide by 0? What is that called?
0.
No, you can't divide by 0. That is what we call undefined. And if I was to graph it, carefully this time, 3 comma 6 and 3 comma -5, look, it's a vertical line, and vertical lines have undefined slope. So if you have 0 in the denominator, it's undefined. As opposed to the next one, the change of y minus -4 over the change of x, 7 minus -5. Both of these become positives. -4, yeah, 0 over 12. 0 divided by anything is 0. What kind of a line do you think that's going to make if the slope is 0? Horizontal. Horizontal lines have a slope of 0. -5 comma -4. 7 comma -4. It's a horizontal line.
It was -7.
Your F5.4 assignment is on Canvas. And notice that you're given points. You could either count the y, count the x, put it as a fraction, or use your slope formula. With these down here, I recommend you use the slope formula. I'm going to have you guys work on evens on this for homework. Please try it. Don't leave it to the last minute. Email me if you have questions. I will answer even if it's at night, as long as it's before 10. Got it? Don't worry about the word problems.
Okay.
All right? You have map testing tomorrow, but this is, quote, due tomorrow on, let's say Wednesday, okay?